Good morning, everybody. Welcome to the webinar. We're just going to wait another minute while everybody trickles in through the Zoom webinar. Okay, we're going to go ahead and get started. Welcome to the webinar today. I want to thank everybody for joining us. It's hard to believe that it's been a year since the pandemic started. And a lot of people on this webinar have been working extremely hard over the last year. And I just want to thank everybody for their service to the pandemic, especially our speakers today. This is a webinar for, quote, junior researchers. These are the people who are actually doing the extremely hard work in the lab, doing writing and analysis, and an opportunity to give them a moment to explain what they're doing and provide us with insights into what they've learned. Today, we're really happy to have two speakers, Abhilasha Shrestha from UIC. She's a research assistant professor. And then we have Patrick Dow from University of Ottawa, who is a PhD student. And our first speaker is Abhilasha, and she's going to get started in a minute. Before that, I just want to remind everybody that you should put questions for the speakers in the Q&A. The chat is not the place to put your questions. Please put them in the Q&A. And if you see a question in the Q&A that you would like to hear the answer to as well, please upvote it by pressing the thumb with the thumbs up. And with that, I think we're ready to get started. So I'm going to pass over to Abhilasha now. Thank you.
Thanks, Ali. Good morning, everyone. Today, I'm going to talk about how we adapted our qPCR from our beach monitoring program to the COVID wastewater surveillance here in Chicago. First of all, I would like to thank the RCN group for giving me this opportunity to talk about the work that we've been doing for the past 6 months. And before I even begin, I would like to acknowledge that the wastewater surveillance effort that I'm going to describe in my presentation is part of a multi-institutional collaborative project funded by the Walder Foundation. And one of the main objectives of this prototype project that we are working on is to establish and evaluate prototype monitoring network that can be used as an early warning system for future public health threats. First, I'm going to give you a brief background about the beach monitoring that we do here in Chicago. So Chicago has 26 miles of lakeshore front that attracts an estimated 20 million people annually here to the city. And the Chicago Park District has one of the most comprehensive beach monitoring programs in the United States, where they sample 20 beaches every day of the week during their beach season, which starts at Memorial Day until Labor Day. And since 2015, the Chicago Park District have collaborated with our labs here at UIC to monitor its beaches using qPCR, allowing same-day notification of the recreational water quality to the general public. However, last year, due to the COVID lockdown, the lakefront and the beaches were closed to the public, so we were not doing any monitoring of beach water here in Chicago. But since we already had laboratory infrastructure in place that we use for our annual beach monitoring program, we had this opportunity to be a part of a grant proposal to pursue monitoring wastewater for SARS-CoV-2 in the Chicago area. But as we all know, there weren't and aren't any standard methods in place for monitoring SARS-CoV-2 in wastewater right now. So what we did is we worked on adapting some of the basic laboratory quality assurance and quality control measures for the SARS wastewater testing from the already established US EPA method that we had been using for our beach monitoring program. So here's the basic workflow of a typical setup that we use for our beach monitoring. We make sure that there is like a physical separation of the clean and the dirty work area in order for us to reduce contamination. So briefly, what we do is we receive around 40 samples by 8 a.m. in the morning every day of the week from Memorial Day until Labor Day. We filter 100 ml samples using a polycarbonate filter, extract microbial DNA using a crude extraction method. So that means there's no kit involved, and then run qPCR from the extracted DNA and get the results out to the public by noon same day. And now here is a setup that we kind of adapted for the wastewater processing. Again, we made sure that there was like a separate dirty and clean work areas in order to reduce contamination. I will explain each of these steps briefly in my next slide. But the main difference here was that for wastewater, we needed to concentrate the virus and then also do a clean extraction using a kit. We couldn't do a crude extraction like we would for the beach water. So this is the first room, also known as the dirty room, where we receive and process wastewater samples. When we're working in this room, we make sure that proper PPE are worn, like gloves and N95 masks, disposable gowns, and safety goggles. All the wastewaters are processed in a Class 2 biosafety cabinet. Virus concentration is done by the addition of magnesium chloride to 25 ml of wastewater samples, and then filtered through a 0.8 micrometer mixed cellulose ester filter. We also spike the samples with bovine coronavirus, which serves as our recovery control. And in this room, we also have a separate refrigerator for storing all the wastewater samples. The second room is our extraction room. We use the bead meeting method and the QIAGEN QIAMP viral RNA kit to extract the viral RNA from the filters. The third room is the clean room, where we prepare all the master mix. This room is again separated from all potential sources of contamination, and we make sure that no DNA or RNA goes into that room. Finally, the fourth room is where we load the master mix to the plates and do the sample loading as well. We use an automatic liquid handler for loading the master mix. But since the volume of the RNA extracted from the kits are too low to be detected by the automatic liquid handler, we load the samples manually by hand. So the fourth room where we load the samples is also the room where we have our thermocyclers. We use the Applied Biosystems QuantStudio 3 real-time PCR system for qPCR, and we have two of them, so we can have a couple plates running simultaneously. So now that I've gone briefly through the method, here are some information about the reagent and primer probes we used for our method here in Chicago. So we use the TaqPath one-step RT qPCR master mix. For the SARS-CoV-2 target, we use the CDC assays targeting the N1 and N2 gene. We also test for the Peppermile model virus, which used as a fecal marker strength, and also for bovine coronavirus, which we use as our recovery control. So before we even started analyzing our samples and getting samples, we had like several questions about how we are going to do this, like everybody else who was doing wastewater surveillance at this time. We knew that generating the CT values and reporting concentrations of what we are seeing in the wastewater was, of course, very important. And that this has been the main focus of the projects that has been doing wastewater monitoring of SARS-CoV-2 around the world. However, we thought that there were equally important other questions, like what is our lower limit of quantification, how accurate our measurements are, like how precise the measurements are, and do those vary by concentration? Can the positives mean that we had contamination in the lab or we had contamination in the field? So from the perspective of a public health researcher, we want to know the CT values and also report the target concentration in the wastewater. But as a lab researcher, we first want to verify that our data are correct and we have a data quality standard. Otherwise, the reported CTs and concentration would not mean anything. So in order to answer some of those questions, we kind of went back and referred to the protocol that we had been using for our beach monitoring program. So we used the US EPA method 1609, which provides the necessary framework for our beach monitoring here in Chicago. So this 71-page document lays out everything needed, from like sampling to analysis to calculating your results to reporting for our beach water project. So the quality control and quality assurance were built into this protocol, which includes like use of no template controls, use of method blanks, positive controls, and sample processing controls. So for wastewater monitoring, we decided to adapt some of these QA/QC measures from our beach monitoring framework and apply it to our wastewater monitoring framework. So we were more confident about our data quality. So next, I'm going to briefly talk about some of the QA/QC measures that we took. So first, I'm going to talk about the standard curves. So for the standard curves, we used a pooled standard curve approach, which accounts for within and between instrument run variabilities. Also, it has been shown that this approach to come up with a pooled model can reduce uncertainty in both the slope and the intercept estimates compared to a traditional single curve approach. All the control materials for the 4 assays were purchased from IDT, and we generated composite standard curves using linear regression. The parameters for the composite standard curves are summarized in this table right here. As we can see that the linearity of the standard curves for all 4 assays was very high, with R squares greater than 0.99 for all 4 assays. Also, amplification efficiencies for the assays range from around 93% to 104%, and these were based on repeated measures for the different instrument runs of standard curves for all 4 different assays. For each plate, we also had multiple reactions of no template control, where we added 5 microliter of PCR grade water to the reaction wells. NTCs were run in triplicates for the N1 and N2 assays and run in duplicates for the PMMOV and the BCOV assay. As you can see from the table, all NTCs came out negative for N1, N2, and the BCOV assay. However, for the PMMOV target, out of 62 reaction wells, we did have 5 reaction wells that came out positive, suggesting that there might be minimal contamination during sample loading for that target. And also, in addition to the NTCs, we also ran method blanks for each of our qPCR runs. For the method blanks, we used 25 mils of PCR grade water, and we processed it exactly like we would for all our wastewater samples. So running the method blank samples ensures that we are not contaminating our samples during the filtration and the extraction process in the laboratory. So similar to the NTCs, the method blanks were also run in triplicate for N1, N2, and in duplicates for the PMMOV and the BCOV target. All method blanks for N2 were negative. We had 1 false positive reaction well for N1. However, all of our method blanks for PMMOV was positive. I will talk about this later in my slide about the challenges we had for the PMMOV target method blanks. And also with the BCOV, we were able to calculate a mean recovery of BCOV in our method blanks, which was around 18%. So we were losing quite a bit of the bovine coronavirus during filtration and extraction. So now that I've gone through some of the QA/QC checklists that we incorporated in our protocol, I'm now going to briefly show you some of our results for the wastewater treatment plant samples that we've been testing. Before I show the results, I kind of wanted to give you an idea of how, like, when we officially got started. So our project was officially started back in September last year, and we started receiving influent and effluent samples from 3 wastewater treatment plants in Chicago in October. In mid-December, we increased the frequency of sampling from once weekly to twice weekly, and then also added influent and effluent samples from 4 smaller wastewater treatment plants, which also serve the Cook County in Illinois beyond the city of Chicago. So by that time, we were receiving and processing 15 samples twice weekly from 7 different wastewater treatment plants. And as of last week, we have collected almost 500 samples, both influent and effluent, out of which we have analyzed 472 samples using qPCR. And additionally, we have also archived over 1,400 filters in our -80 freezer that we can use for future analysis. So here's the results for the Stickney wastewater plant. I don't know if you all know that Stickney is one of the largest wastewater plant in the world, and it serves around 2.3 million people. And on average, the treatment plant processes 700 million gallons per day of wastewater and has a capacity to process almost 1 billion plus gallons a day. So the N1 influent concentration ranged from 9,000 gene copies per liter to 1.9 gene copies per liter. For the influent from Stickney, the N2 influent concentrations from Stickney range from non-detect to around 700,000 gene copies per liter. And for the highest N1 concentration in effluent sample was around 50,000 gene copies per liter. Oh, I just wanted to include this note, a fact from Stickney wastewater plant, just to give an idea of how long it takes when someone actually flushes the toilet in one part of the city for it to get to the treatment plant and eventually get processed. Here are some results from the other 2 wastewater treatment plants, O'Brien, which serves the north side of the city of Chicago, and Calumet, which serves the south side. For O'Brien, the highest N1 concentration that we saw was around 2 million, and same as for Calumet, where the highest N1 concentration was about 1.9 million gene copies per liter. Here are some results from the smaller wastewater treatment plants, Eagan, Hanover Park, and then we have Curie and Lemont, that all these small ones serve the suburb areas and not the city of Chicago. So I also wanted to briefly talk about some of the challenges that we faced while we were getting this project started and running. So before we could even start receiving wastewater sample, we had to ensure that all the PIs working in the lab and all the students working in the lab were properly trained, and we had all the required certification for our lab to process wastewater samples for SARS-CoV-2. It took us almost a month working with our environmental health and safety office to get institutional approval to start receiving and processing wastewater samples. Another issue, like everyone else faced, was the supply chain issue. One of the main reasons for us, the for choosing the viral concentration method and the RNA extraction method was due to the availability of the QIAGEN kits and the laboratory supplies. The next one was choosing the laboratory method and optimization. In Chicago, we had to come up with something pretty quickly. So what we did is we applied this fast and furious approach where we reached out to different labs. We reached out to New York University lab, we reached out to UC Berkeley lab, we reached out to University of Wisconsin, Milwaukee lab, and we asked them what had worked for them. And then we customized their protocol accordingly to make it work for our lab. The next challenges that we have faced and we have continually facing is this PMMOV contamination issue in our method bank. I have worked through different cleaning methods. You know, we have tried different extraction approaches, and we still end up with this contamination. So if we decide to use PMMOV for correcting for fecal strength for our data, we need to figure out how this will affect, how this contamination is going to affect our normalization. And lastly, everyone working in our lab is either a graduate or undergraduate student. So we had to basically work around their semester schedule to get our laboratory work done. And finally, I want to end with a couple of the next steps, what we are working on currently. Our team, some of our team members have already started working on the genomic surveillance of SARS-CoV-2 in wastewater. The samples might be running just as I am talking right now in the Argonne lab. We will also start sampling city sewers for hot and cold spots in the upcoming weeks. And in the last couple of weeks, we also have had conversations with the Department of Aviation to start testing the sewers for the international terminal at O'Hare Airport, and also feasibility to test wastewater from incoming international flights. And lastly, we have also been in talks with the Illinois Department of Public Health, where they want to start a statewide wastewater surveillance and sequencing program. Lastly, I just want to acknowledge all the people who have helped us out in the last 6 months to get our lab up and running. My graduate and undergraduate students who are here in the lab every day to process samples. Andrea and Catherine from New York University, Hannah from UC Berkeley, Sandra McClellan and Suchen from University of Wisconsin, Ira Heimler from UIC School of Public Health, John Lavelle from Current, who gets us all our samples every week, and then the entire WBE Slack group for all the answers that I had, like for all the questions. And thank you again for listening to what we've done here in Chicago. And if there are any questions, I would be happy to answer. Also, happy St. Patrick's Day, everyone.
Thank you. Thanks so much. That was an excellent presentation. I certainly appreciated some of the QA/QC details. And we do have some questions in the chat. As a reminder, please put your questions in the Q&A and upvote any questions that you see there that you're curious about. I have my own, so I'm hoping we can get through some of these. One question that, okay, people are upvoting as I speak. Okay, so one question I had is actually about, I think I knew that there are some plants in Chicago that are combined sewers and have issues with intense rainfall events. So curious if that's true, if that's true of the plants you're sampling, and what impacts that has had on your results, or if you've been able to detect any impact of rainfall.
So yes, you're correct about the combined sewers here in Chicago, and we haven't had really wet days since we started collecting, except for the snow melt that we just had recently. But we haven't really looked at, pinpointed those days and kind of looked at our data on like what we are seeing. Like, we could probably look at our PMMOV data and kind of compare our data.
Okay. The next question.
The snow melt.
Oh, sorry. I think I had a connection issue. I can hear you now. Okay, so the next question is about whether or not you've noticed that data is more variable in the smaller treatment plants compared to the larger treatment plants, if there's any correlation between the size of plants and the variability in the data.
We have seen variability in all 7 plants, but we haven't really looked at like differences in, we do see variability like all around.
Okay. Have you gotten a chance yet to compare your wastewater data with the case data?
No, actually, we haven't yet, but we have been in talks with the Chicago Department of Public Health because they are one of the partners for our project, and coming up with ideas from how we can do that, that compare data can be made available to the public.
Yeah, that dovetails well into the next question, which was basically how you're collaborating with public health departments and how if you're reporting back to the wastewater treatment plant.
We do. So we just had a meeting with the MWRD, which oversees all our wastewater treatment plants. Last week, and then we have weekly meetings with our partners in Chicago Department of Public Health. And like I mentioned, we are also in talks with the Illinois Department of Public Health, where they are trying to set up wastewater surveillance and sequencing all over the state. Okay,
cool. I want to dovetail in a little bit on some of the QA/QC results you showed. So this is probably a nice sanity check. Someone else in the audience also sees PMMOV in method blanks. So they're curious, I guess, what you think is causing this, and how much higher it is how the levels compare in the blanks compared to the samples.
So the levels in blanks are way about even like 1,000-fold lower than in the sample. So sample concentration of like PMMOV in sample concentration is like really high. So it's lower. It's much lower in the method blanks, and I seriously right now, I do not know what might be causing it, because, I have been trying to do like, cleaning. We have changed our protocols for, like do the extraction. We have changed like how we clean our filtration unit, how we clean our manifold, vacuum manifold. But I'm still seeing some contamination. The numbers have gone down significantly as the CTs have become much, higher over the time, but we still cannot get it like above 40, CT. So I'm still working on it. If there are ideas that people have, please let me know, because I will try it out, because it has been really bothersome that, we have these positive PMMOVs.
Yeah. Okay. This next question was upvoted a little bit. So did you see any trends in the samples that were near the airport? Especially since, Chicago is such a busy airport and always had international flights. Also, on the variant work, have you had any results from the variant work on the samples closer to the airport?
So the samples closer to the airport, I'm assuming you're asking me if the wastewater treatment plant that gets the
Right.
sample from the airport.
Yeah.
Okay, it looks like she lost her connection, which is unfortunate, but it's also time to move on. So Patrick, do you want to go ahead and share your screen now?
Absolutely. So thank you. Share my screen now. Okay, it should work, hopefully. Fingers crossed. All right. I think we're good to go.
Yeah, looks good.
All right, perfect. So welcome everyone. My name is Patrick Daoud. So essentially today we'll be giving a presentation on wastewater surveillance of COVID-19 and variants of concern in Ottawa, Canada. So essentially this was prepared by myself, Elizabeth Mercier, and my our supervisor, Dr. Robert Deltola, and I'll be presenting today. So essentially, first, let me start with just giving thanks to everybody who's made this possible. So obviously the whole group, we've grown significantly. And I think really we need to, acknowledge that, it's not only a one-man team, it's, a huge group that's working on it. It's a huge combined effort, and really also acknowledge all the institutions that have been helping us. So namely, for example, Province of Ontario, to give you a little bit of a landscape change in what's happening in Ottawa and in Ontario in particular. So in Canada, governmental agencies have not been very fast at allowing any funds to go towards actual, COVID-19 testing in wastewater. Not a lot of people have tagged on from the beginning. And Ontario was the first province, and the government of Ontario was the first to actually allow and a significant amount of money to actually do this, to do an initiative throughout the province. And now we're 13 labs, academic labs. So they thought about tapping into academic labs to really do this type of servicing and, for the greater good. So I really want to acknowledge their help in this matter. So let me start by telling you a story about, SARS-CoV-2 wastewater-based epidemiology in Ottawa. So in Ottawa, we were one of the first groups out the door back in April, but essentially really then other groups tacked on, but we were kind of the first to actually go out, put data online and so on. So in Ottawa, we have a very good test case for wastewater-based epidemiology, as the vast majority, and if don't quote me on it, I think it's 91% of the population is actually sewered through one single treatment plant. So when we're talking about wastewater-based epidemiology, we're actually looking at the vast majority, over 1 million people in that single plant. So there's not multiple sites. It's very, very easy for us to sample. So this is a map actually of the transit times. You can see out in the west, there's a lot of lift stations, transit times of 35 hours, which may not give you the best data. But as a whole, Ottawa was a very, very good location to start working with, just because we had such a large amount of the population on one single plant. So the plant, it's the Robert O. Pickard Environmental Center, or ROPEC for short. And essentially it's a plant that's an activated sludge plant, conventional activated sludge, does primary treatment and removes VOD, and then basically it sends the outflow to the river. So there's no nitrification or anything else in this plant. So to give you a little bit of an overlay of what we do, first, we started looking, contrary to a lot of what I'm seeing in other groups, we're looking at solids, wastewater solids. So we looked at the literature, we thought we'd have to go at what's in the solids, and specifically in the primary sludge. The reason for going into primary sludge and from the get-go was really due to fears of, encountering, for example, either dilution effects or snow melt effects, things like that. And we ended up just going with the primary sludge, which has a control over those effects, and it can actually help us, avoid having big impacts or big data swings on the data. That's what our initial fear was. So we actually ended up going through the primary sludge, and that turned out, I think, to be a pretty good bet. So essentially, we take primary sludge, centrifuge it down, we get a pellet, and then from the pellet, we're actually able to just do a nucleic acid extraction with a QIAGEN pyromicrobiome kit, do the quantification, give it a little prayer to ensure that we try to have a good PCR result, and then we normalize the data for PMMOV, pepper mild muffled virus. So essentially what we found is that PMMOV actually allows us to actually reduce the noise of the data. So essentially we wanted a method. The reason why we went through a kind of a very simple method with just centrifugation as the only means of concentration was that we wanted to have one goal in Ottawa. In our hometown, we wanted to have one goal, which was to basically be able to provide same day reporting or very early next morning reporting to our public health units. We've been working with this with our public health units from the get-go to actually, just do it and work with them hand in hand, get the information out. And Ottawa Public Health have been very good at this and being fully transparent with the population. But however, this means that we need to collect samples by 8 a.m. and we need to have qPCR results and a report out by 5 p.m. approximately. So this is really what we strived on, and what this was the whole goal of our method to be optimized from the get-go to get rapid turnaround time. So now let's talk about the first phase of the project. So essentially, as we started working in April, we were actually on the downward slope of really the first wave out in Eastern and in Canada in general. So essentially, when we started meeting for public health units, we had a couple of samples under our belt. We're looking at the results, and in dark gray here, you actually see the epi data. Obviously, the Ottawa Public Health Unit wanted to compare what does this say in terms of wastewater versus epi day cases, and essentially, it was a very tough sell. It was rough. I'm not going to lie. We weren't really seeing much correlation. And we started looking at maybe we are not correcting or normalizing our data for the right things. Should we normalize for flow? Should we normalize for, potentially mass flux of solids in the plant? Should we normalize for other biomarkers? And then we started going back to literature, seeing, hey, what can we normalize for? And then we found about this wonderful little virus. I see some people see it as a problem, but we love pepper mild mothball virus. So essentially, we found that when we take a data set and we actually normalize it with the copies per PMMOV, or pepper mild mothball virus, which is basically one of the most abundant viruses in fecal matter, we're actually able to normalize our signal for actual fecal matter. And when we're looking at primary sludge, that's essentially what it is, right? It's a concentrate of fecal matter and other solids in your wastewater. And suddenly we thought we had something going here. It was a better agreement with the data. And I think Public Health Ottawa actually started, looking at it and saying, yeah, that might actually work. So essentially, just to give you a primer on PMMOV, if you're not aware what it is. So here's a picture, an SEM picture published very recently of SEM. It's a rod-shaped virus. It's basically a plant virus that's found mostly in peppers, but also sometimes other fruits and vegetables. It's useful as a fecal contamination marker in water. So essentially, if you have PMMOV in natural waters or wastewater, is a good indication that you have human fecal matter, as it's not found frequently shed by animals. It's the most abundant virus in the human feces, or one of them at least. And finally, we found that when we're starting to look at wastewater solids and we want to do SARS-CoV-2 wastewater-based epidemiology, dividing or normalizing, in any case where you just divide our SARS-CoV-2 concentration by the concentration of pepper mild mothball virus really helps us track the epidemiological data much better. Actually, it gives us a very good, trend normalization. So just one note on pepper mild mothball virus, if you ever want to try it with your own wastewater-based epidemiology efforts, it's diet impacted, meaning that if you're testing wastewaters at a very small scale, for example, a neighborhood level, a facility, you're looking at a prison, a jail, or a homeless shelter, a hospital, it will be impacted by diets, which means that basically if you have, spicy Italian salad on that night on the menu at the cafeteria, you might see an actual increase in pepper mild mothball virus that will throw off your normalization. So this is not, I would not advise to use pepper mild mothball virus as a normalization factor in very, very small sewer sheds that you're testing. So phase 2 of our project really was detecting the next wave. We basically rode down to the tail end of the first wave in Canada. Then we want to say, well, hey, can we keep doing this? Maybe start having higher frequency and looking if we can detect the next increase. So what we found essentially is that when we started looking at data in July, we started having a little peak in the SARS-CoV-2 RNA signal. And we found that when we compared it to the actual epidemiological data, we're able to start seeing peaks in the wastewater SARS-CoV-2 signal approximately 48 hours prior to increases in clinical tests in Ottawa. And this is when we were doing sampling every 2 days at a wastewater treatment plant, so every other day. And then we looked at hospitalizations and essentially people going into hospitals due to SARS-CoV-2. We found that we're essentially 96 hours plus from the peak in number of hospitalizations that we would have. So this really was just basically a small test at the very beginning. We had basically a small increase in July, and we would basically look at that throughout the whole rest of the project to see would this hold true. So then, once we showed these graphs to Public Health Ottawa, and they were really, really interested and said, okay, yeah, they're buying into this, and they said we want to have essentially daily measurements, and we want to have this online. We want to share the data online with the residents of Ottawa. So this is, something that doesn't happen all the time. Sometimes public health units, cities want to hold it a little bit closer to their chest. But in this case, City of Ottawa Public Health wanted to put it all online. So then that's what we started doing. So we started doing daily testing since basically September in Ottawa. So we started doing daily testing for SARS-CoV-2. Obviously, that meant a lot of more work on our end, more people, more samples, more driving to sites. In this case, for Ottawa in particular, we're not getting anybody to deliver samples to us. We're each taking turns going to collect samples every day in the morning to actually make sure he gets into the lab at the right time. And essentially, this gives us basically daily monitoring and a really good wastewater indicator, SARS-CoV-2 prevalence indicator for the city of Ottawa. So essentially, this is just essentially what was the actual situation in Ottawa throughout the whole pandemic as now. As you can see right now, this was data I believe from yesterday. So we're currently in third wave, so to speak, in Ontario, the province of Ontario, and then government officials have announced as such this week. But essentially, really now, if you look at the epidemiological data, I want to bring your attention to the actual teal lines here, the teal gray or tealed area. So essentially, teal area is the number of new daily cases per day, and the actual orange data is our epidemiological data. So this was the test bed or the little test we had in July. But as you can see, we have a very good tracking of the wastewater-based acquired SARS-CoV-2 signal and the clinical data. And this really became a really, really good indicator for Ottawa Public Health. And they started believing it a lot more. And then essentially we turned out to a point where we came out to a point where essentially, I think, especially because when you have changes in variations in how you do the clinical testing, how many people come in to get a clinical test, you have schools opening, there's a lot of variability in clinical testing. Not everybody wants to go get tested. And now essentially what's happening is you got public health officials that really start to look at the wastewater data as almost a datum instead of just using it the clinical tests solely. So they use it to confirm and they use it to actually predict. So I think that we have proof of concept now at this point that PMMOV can normalize SARS-CoV-2 signal in certain, if you have a good large sewered area, can actually help you guide and help clinical health measures. So essentially, this also is one of the things that happened in Ontario. So there's actually been, obviously on the news, little spats between public health officials, the mayor, the city of Ottawa, and the provincial premier arguing as to if they should actually reopen or stay in lockdown or extend lockdown measures. And essentially, the premier of Ontario actually stated or cited the wastewater data as something that actually was driving their decision to keep Ottawa locked down for a longer time period. So really, you can see that when you start building a system from the ground up, start having strong foundations, strong bones, then you grow it up over time. And actually, at the end of the day, you've got a lot of people paying attention, and a lot of people basing their decisions on what our lab is producing daily, which is very humbling to us. And we're very happy to be able to provide the service for everybody in Ottawa. So essentially, City of Ottawa, they went with a very transparent approach. So we have, if you're ever interested, www.613covid.ca is essentially where the data is posted. It might be 1 or 2 days late, depending on how often they update the website. But essentially, it's a website that provides daily updates for the wastewater information for all citizens in Ottawa to see. It's freely accessible. And when we're looking at the actual, Google Analytics to see who accesses it, very happy to see that there's actually, a very good constant, about approximately 1,000 to 1,500 people that access it daily. So there's actually people that care, which is always good in science when people actually take a little bit of attention, pay a bit of attention to your to the work you're putting out. So essentially, after we got this going, and now this was basically our daily tasks among 13 other sites that we test periodically throughout the week. Essentially, we started looking at variants of concern. So variants of concern were something that happened as well in Canada, and we were very worried about them and what that would mean for the wastewater data, and also for just public health. What would happen in terms of number of deaths, number of severe SARS-CoV-2 cases. So essentially, from January, we really started working on the assays. And here, I'm just going to outline, this is really the work of Dr. Tyson E. Graber, one of our colleagues and our team members in the Ottawa CHEO group. And he's really been the actual #1 person working on this, developing the assays. And what he's done essentially, so I'm not going to delve into the actual specifics of the assays. The preprint is out now if you're interested. And that we provide the primers, probes, and everything. So it's an assay that we were able to validate. And how we validated this was actually with wastewater from a neighboring town, another town called Barrie, Ontario. So Barrie, Ontario was very, well, it was unfortunately became famous on the news in Ontario because it had a long-term care home where they had an early outbreak in February of the B117, the UK variant. And in this retirement home, they had approximately 129 residents. And over a 30-period day, essentially, they had an outbreak of the UK variant. And over a 30-period day, or 30-day period, 69 of the 129 residents passed away from SARS-CoV-2. So obviously for this, we were actually monitoring this right at the beginning of the outbreak and looking for the B117 variant through our qPCR, our new qPCR assay. And we were actually able to detect it at very high concentrations, as outlined here in the orange graphs, from the actual wastewater taken at the plant and at the retirement home itself. And now, basically, once we were able to validate that our assay actually worked with samples from Barrie and other towns in Ontario that have higher propensity of or a higher number of cases of the variants, then we actually started rolling this out to all sites that we test. So all sites that we test that come back positive for SARS-CoV-2 or COVID-19, we then put them on, take the same samples and test them twice a week for variants of concern. So we're now doing this for the UK variant. And Dr. Graber, again, as fantastic researcher, fantastic guy, he's actually now come up with assays for the South African variant and the Brazilian variant. So we don't have very much Brazilian variant anywhere right now in Ontario, very few cases. However, in the Toronto area now, the greater Toronto area, there are quite a few South African variant cases. So now we're working and we're sharing, these protocols and these assays with all partner labs, essentially, that we've been working with, that we've developed over time to actually allow them to actually test for the different variants of concern, including the South African assay. Now, just as one point, basically, the way we actually validated in Barrie the assay for the UK variant, we actually also did sequencing, so metagenomics on the actual samples that we got, and we actually were able to outline that we were actually on one specific, right here on the bottom right, we actually had a specific allele that was found for that was confirmed to be the UK variant in our samples. So essentially, it's a short one. Just wanted to give you a little bit of an update what we're doing in Ottawa. And again, if we have any questions, we're always happy to collaborate with anybody. For right now, I think it's still a public health, I'm going to say emergency. So if we're always happy to share and give out information, and anything you might need help with or have questions about, we're always here to help. And I just want to acknowledge really thank you to whole groups. I know now our group and colleagues have grown substantially over time. We want to thank, CHEO, EU Ottawa, City of Ottawa, Ottawa Public Health, City of Hamilton, Office of Hamilton Medical Officer of Health, University of Waterloo, University of Windsor, and the Canadian Water Network. And of course, the province of Ontario and the MECP, which would, if without their generous funding, would not, and having believed in us, we would not have been able to get here or perform any of this work. So thank you very much.
Thanks so much, Patrick. That was a really great presentation, and you guys have obviously been very busy. It's awesome to see. I know we're a year out now. It's really great to see all the work that's been done and really be able to celebrate that. So to both of our presenters, thank you so much. We do have some questions, and if you have any more, feel free to add them to the Q&A or upvote ones that you want answered. I'm going to start just right ahead at the top. So I noticed this as well. It looks like the March concentrations from currently are increasing in wastewater while cases are staying relatively flat. So there were a couple of questions about this. Do you have an expectation for why this might be? And do you have any data on changes in testing or vaccination that could be associated with that increase?
Right. So I will start with saying that vaccinations in Canada are very, very slow. They're federally managed, and they're not as well managed as in the US. I mean, they're doing a good job. They're doing the best they can. And then, you know, that's great for them. But the vaccine rollout rate, if you're ever curious, in Canada is very, very low compared to the US or many other countries, the G7. So essentially, we don't think that vaccines are having any major impacts. You know, right now we're still at vaccinated or 75 years old or plus. We're just hitting now to 65s last week. So I don't think vaccine are playing a huge role in the wastewater shedding and the wastewater numbers that we're seeing. However, right now, what we're seeing coming down to the actual clinical cases, that's the same question we're having right now. And now with the variants of concern that are starting to come into play, starting to be detected in different places, we don't know how the shedding dynamics are changing in patients that are infected with variants of concern. So I'll be very cautious here. I don't know if that's the cause, but I don't know if a smaller number of patients are shedding more viral particles versus what we would call wild type or ancestral SARS-CoV-2. Additionally, there was a lag and basically there was basically a buildup of tests that had not been analyzed in mid-March in Ottawa. We've confirmed with Ottawa Public Health. If we look at daily test cases now, they're approximately 1.5 to almost 2 times more than they were. You know, like even today, yesterday, and the day before, we're very, very close. We're seeing significant increases in the number of clinical tests that are coming back positive. So, and finally, we think, you know, maybe we've had, you know, March break here in Canada recently, and we're wondering if that maybe just with schools, we might be having maybe, you know, people or, you know, kids, for example, that have the sniffles, but are not necessarily getting tested for SARS-CoV-2 every single time, and we might actually have mostly asymptomatic carriers. So these are all things. We're not saying that it's any of these in particular, but this is what we're thinking. So we're definitely paying close attention to the data sets.
Yeah, I can definitely, you know, that's one of the big challenges is parsing apart all the possible options. So, all right, the next question here is for the Graber et al. Paper, or I think it might still be a preprint you mentioned, for sequencing. Do you know if that outlines the lab workflow and all the details there for others who might want to take up those methods?
Yeah, no. So right now it doesn't outline. So it was not we were trying to make this preprint really in this mini method paper, if you want, really focusing on the qPCR assay to roll it out. So we've done it, but we don't have the full protocol laid out. But we'd be more than happy to share that with you. It's going to come in a future publication. Right now, it's just finding the time to write is difficult. But definitely, if you need that information, we can get it to you.
Great, thanks. And then, yeah, I know that you guys have had a lot of, in certain cases, success communicating your data with public health departments. I know a slow process, but so what would you say from your experience are the major lessons learned or advice you could give about communicating this data to both public health departments and the broader public and government officials?
I think you have to do it right the first time, and you have to make sure that, you know, the proper obviously we haven't touched as per the previous presenter, we haven't touched on QA/QC, but there's a lot of that going on in the background as well. And you have to be sure that you're using the right material, the right standards, and you're doing the right QC to actually have a reliable data set. Because it's not just, you know, I think now we're seeing it a little bit more now, but, you know, I would say a year ago, if you got data out, everybody was like, yay, good job, it's great. Now I think people are being a little bit more selective on the QA and QC. And I think at the end of the day, the one advice I could give is make sure your data is right, because it's the worst thing to go back to your public health unit and saying, hey, you know, we messed up, or a factor of 10 off or a factor of 2 off. This kills the confidence. And the same thing happens for the public. If you show the public it's a website, you know, right now, Ottawa Public Health had enough confidence in us, and thanks to them, you know, having confidence in us. If we go and we change a data set and you have a factor of off that changed, like, we will get emails and Twitter will erupt, at least the local Twitter sphere for Ottawa will erupt, and people will be asking questions. So that's the worst thing that can happen. You need to be 100% sure that your data is correct, because you can't go back and change it.
Yeah, absolutely. And I did have a kind of a follow-up question, just a logistical one on that. I know you mentioned that one of the big things you guys started out trying to do was make sure that your data was coming out quickly, in ideally less than a day. So what sort of, if just like touching on briefly, what sort of QA/QC or flagging of poor samples do you do in that time frame? Like, what standard have you set for that? And is that kind of obviously wrapped into this rapid turnaround protocol that you have in place?
So for example, things that we'll do on every single qPCR plate, and this is something that's really limited our output and made the costs skyrocket. But essentially, we do obviously standard curves for every single analyte on every plate that we do. We also do essentially inhibition controls for every single PCR plate that goes in. So we check for inhibition. And then periodically throughout the week, not on every single plate, but we'll do, for example, we also have NTCs, all that, yeah. But then we'll do method blanks periodically, and also do spike-ins for recovery efficiency calculations periodically. So several times a week, we'll do these. And now this is actually a requirement now to be part of the Ontario provincial program. Some of the things were actually that all labs have to come up to a certain standard in terms of QA/QC to report the data. So, yeah.
Awesome, thank you. All right, one more question over here was related to the transit times. Some of them obviously being really high. Have you noticed or tried to address any challenges related to transit times? And then kind of a follow-up sewer system question. Is the system in Ontario a combined sewer, and have you tried to look at any effects of increased flows to the sewer system?
Right, for sure. So question first for the transit time. Yes, we're well aware. I mean, there's not much we can do. Like literally the community is like 40 kilometers away, which is like 26 miles or something. So it's quite far. So there are some limitations to that, and for sure, I mean, I think what this means essentially is that we're days in the past. If you're living out, for example, that community is called Carp. If you're living in Carp in that neighborhood, you are essentially, a day and a half late on the data. That's all it is. So if you want to know what's happening in your location, it's going to be, you're living in the past. But coming to the actual question regarding, sorry, I forgot the second question. Second part would be
just related to the combined or separated sewer system. I can't remember.
Right. So Ottawa, being the capital of Canada, if you have to come in the summer, it's great in the summer. Come and visit us once the pandemic is over. Essentially, there are some portions of the city that have combined sewers in the very older parts of the city. We still have some combined sewers, but by far and large, all the newer developments, for I could say probably the last 15, 20 years, have been separated with storm and sanitary. But there's definitely an impact of that. So we won't lie, we see it, we can see it, but doing meta-analysis, we've looked now at a year's worth of data, looking at different parameters in the primary sludge and the influent. Just looking back, we did that I think 1 or 2 months ago, looking back at primary sludge and influent versus precipitations, snowmelt, and we're not seeing it's a very, very minute effect in primary sludge. There are some small, there's a positive correlation with, or we found a correlation between just minute changes and different parameters in the primary sludge and precipitation, but it's like less than 5 to 10%. So in this case, it's within the margin of error of qPCR, just and variations intraday.
Great. Yeah, thank you so much. I know there's a couple more questions that are still in the Q&A, but I want to be respectful of time, so I think we'll close it off here. And if people have follow-up questions for Patrick or Abhilasha, I'm sure that they would be happy to answer those offline or still online via email. So thank you again to both of our presenters. This was a really great webinar, and we'll have our next webinar coming up in another 2 weeks. Everybody have a great rest of your days, and thanks again for joining us.
Thanks, everyone. Have a great day.